In this video, we're going to look at initial value and rate. We'll look at a few other things as well, but I think that'll be the main focus here. So here we have a question where a plumber charges a flat fee of $60 for the visit, for each visit, plus $80 per hour she's at your house. So the first thing we're going to do here is to create a table showing the cost for up to 5 hours. We're going to start this table by putting the time first. Oh, hang on a second. Let me fix that up. Grab a pen. We'll put the time here. And we'll put the cost over here. So in this case, the cost depends on the length of time. So we say that the cost is the dependent variable and the time is the independent variable. So I'm going to start here at 0 hours. And it might seem weird to you that you might have a plumber come for 0 hours. But let's say you call the plumber. The plumber's on their way, but in the meantime you fix whatever plumbing problem you had. But the plumber's still at your door. The plumber has made the visit to your house, and they're still going to charge you that flat fee, in this case of $60. Rightfully so. You know, they've spent their time traveling to your home, and you're saying that you don't need them. So here we go. We've got our time here for 0 hours. How much does it cost? Well, this plumber charges a flat fee of $60. So right off the bat, before they even step into your house, that trip is going to cost you $60. We also know that the plumber is going to charge $80 per hour. So she's there right when she gets to your door, it's $60, and for every hour after that, it's going to be $80 on top of the $60. So $60 plus the $80 will give us $140 here. I'm just going to show, we've done this sort of thing before, show the difference from here to here. So to go from 60 to 140 means that we added $80. And again, we'll do the same thing for 2 hours. I probably won't have room to squeeze all 5 in here, but I'll do my best here. So we're going to add in $80. So 140 plus 80 should give us 220. See if I can make that small enough. And again, we added $80 to go from here to here. So remember, we call these things first differences, and in this case, they're all going to be the same. And then we're going to, for 3 hours, we're going to add in another $80. So 220 plus 80 will give us 300. The next one will be 380. And then we add 80 to 380, we should get 460. And again, we've got those first differences. They're all exactly the same. That tells us that this is a linear relationship. It's going up by the same amount every time. If we were to graph it, and we will graph it just roughly without a grid, but so you can see what's going on. So we increase by $80 every time. Alright, so let's do a quick graph. As I said, it'll be quick just to kind of give a sense of what this looks like. And I know the question didn't ask for that, but we may as well have a look. Oh, need to practice my drawing here. Let's try that again. Or maybe I'll use the straight line tool. That might be even easier. There we go. Straight line. Straight line. Alright, so just a reminder, I know it's been a while since we've done any kind of graphing, but the independent variable goes along the x-axis here, the horizontal axis. So we'll call this time, and we'll put the cost here, or the dependent variable, along the vertical axis. This is measured in dollars. Time was measured in hours. And again, I'll just do a rough sketch here. So we had at 1 hour, 2, 3, 4, and 5 hours. Well, we know that we're going up by $80. It might be worth just using that as our scale. Say, hey, here's $80. Sorry, that's not going to work out very well. I'm going to run out of room. Put that back. Sorry, just to keep this nice and simple and so I don't run out of room, I'm going to go up by, let's say, $100 chunks. 2, 3, and 4. I may not have room for the last one, but so if $100 is right here, 200 here, 300, and 400 up here. So I'm going to start by plotting, I'll do this in a different color. I'm going to start by plotting this point right here, 0 and 60. So 0 and 60, probably just over halfway, obviously. So somewhere in here, and again, hard to do without grid paper, but we can kind of eyeball it and get an approximation. For 1 hour, it's $140. So almost halfway between the 100 and the 200, a little less. And then it's 220. And if you do this on a piece of graph paper, you'll see that these points should all line up perfectly in a straight line. We talked about this being a linear relationship. And then 380. And so when we say it's a linear relationship, I'll try to make those dots a bit bigger so you can see them. We should be able to take a ruler and just draw a nice straight line through all of those points. And because we didn't use grid paper, they're off by a little bit, but you can see more or less. Whoa, that didn't work out so well. Hard for me to let go of my pen at just the right spot. It wants to snap to some kind of grid here, I think so. There we go. So that's what the graph would look like. A couple things to note here about the graph. The first one here is that the initial value, we've talked about this before, but I know it's been a little while. The initial value is this point right here on the graph on the y-axis, so we call that the initial value. The other thing to note is that we can find the rate on this graph by looking at how much do we go up by and how much do we go over by. So the rate here is whatever the difference is from here to here. So here it was $80 for every 1 hour. And now I drew that specific triangle. I could have drawn any number of other triangles. So I could have, if I wanted to, I could have drawn this triangle here, and the rate would be exactly the same. I'm going to jot down the information about the rate because, as I said, it's been a while since we talked about rate. So the rate here is equal to the rise on our graph divided by the run. So how much we went up by divided by how much we went over by. So we call this the rise, and we call this the run. So our rate is our rise divided by our run. In our case, it's 80 divided by 1. And don't forget the units here. This is $80 per 1 hour. So our rate is $80 per hour. And that's not a surprise, given that that's what we had in the question. But notice how you can see that $80 per hour show up on the graph. It shows up here by doing the rise over the run, so in the graph. It also shows up here as our first differences, the $80 going up by 80 every time. And we can do it algebraically with the calculation over here. Now I did the one calculation. Let's do this triangle here that's in, hard to see that, this triangle here that's in green. So this went from 1 hour all the way up to 4 hours. I just want to show you that it doesn't matter where we do the rate calculation. So we went from 1 hour to 4 hours. That's a run of 3 hours. So again, the run along here is 3 hours, and we want to know how much we're going up by here. Well, we started here at 1 hour, we were at $140. And then over here at 4 hours, we were at $380. So that to me looks like it is approximately $240 if I did my math correctly, which works out to $80 per hour. So going back to that unit rate that we were talking about just a little bit before the break. So that's $80 per 1 hour. Same sort of result. All right, let's create an equation here. To make an equation for the cost, well, how much does this plumber cost? Well, she costs an initial $60 plus $80 for every hour. Now, if we don't know how long she's coming, we can use a variable in that spot to hold the spot of the number of hours. So C being the cost, N being the number of hours, and in order to figure out how much it's going to cost, we substitute however many hours we want into this equation for N to figure out what it's going to cost. So if we want the plumber for 10 hours, We'll do 80 times 10, which is 800 plus the $60. Now I've written it like this with the 60 and then the 80n because it made sense from the original question with this 60 and 80n. We often see this written also like this, and I know some of you did this in class when we were doing some of the patterns. Wrote it as 80 times n plus that $60. So either way is fine. Those are both equivalent. Question here, what is the initial value? Remember, the initial value is this value right here on your graph, or this value right here in your table, or the flat fee. What does it cost for 0 hours? So the initial value, and I'll just abbreviate that IV for now, initial value is equal to $60. And what does it mean? That's important too, not just what is it, but what does it mean? This is the cost for 0 hours. And then what is the rate? Well, we've already found the rate right over here, $80 per hour. Again, it was given in the question as well. As you get good at these, you can kind of just read the question and pick out some of these values. $80 per hour. Now, this goes back a little ways talking about direct and partial variation. Just a reminder, a direct variation is a relationship that passes through the origin. So in other words, it costs $0 for 0 hours. So this is what we call a direct variation. Whereas this one here is a partial variation. So there's the partial variation. If the initial value is 0, it's a direct variation. If the initial value is non-zero, it's a partial variation. Here, the initial value was non-zero. We saw that here, and we saw it over here. So this is a partial variation. Since the initial value is non-zero. Alright, so that's a quick introduction to initial value and rate, and tying it to a bunch of the stuff that we've done before. So there's some graphing here, there's some coming up with equations, and just kind of getting comfortable with the terminology.